Ethereum is one of the largest decentralized networks in the world. At its core, it isn't powered by a single foundation or company, it's powered by thousands of computers, called nodes, all running the same protocol and agreeing on the state of the blockchain. And in this video, we're going to break down exactly what it means to run one of those nodes. We'll look at the software, the hardware, and why it's so important for decentralization. Whether you're a developer or just someone passionate about Ethereum, this will give you the full picture of how to participate in Ethereum's trustless ethos of don't trust, verify. So let's start with the basics. What exactly is a node? A node is simply a computer running Ethereum software that connects to others in the network. Its job is to validate transactions, check blocks, and enforce the rules of the protocol. Since Ethereum's merge in 2022, every node needs to run two pieces of software. The execution client, which processes transactions in the Ethereum virtual machine and keeps track of balances, then the consensus client, which runs proof of stake and ensures the network agrees on the blockchain's head. And if you stake 32 ETH, you can also add validator software. That's the piece that actually proposes and attests to blocks. Together, these clients form the backbone of Ethereum, keeping it secure, decentralized, and resilient. But what does running a node actually look like in practice? Let's break it down. Running a node really comes down to three things. You've got the software, you've got the hardware to handle it, and you stay online to keep in sync with the rest of the network. When you first start, your node has to download Ethereum's history. That process is called syncing. Modes like Snap Sync make it quick. You can be up and running in hours instead of weeks. A full sync, on the other hand, replays everything from Ethereum's very first block, giving you the most complete history. Once you're caught up, your node starts doing its real work, checking transactions, verifying blocks, and sharing data with others. And this is where the question naturally comes in. Why bother? Why would anyone want to run a node in the first place? First, privacy. Instead of trusting a third party to feed you blockchain data, you're pulling it straight from the source. That means no tracking, no middlemen. Second, security. You're verifying everything yourself. No one can slip in false data without you noticing. Then there's censorship resistance. The more independent nodes online, the harder it is for anyone, governments, corporations, whoever, to silence the Ethereum network. And finally, it's about sovereignty and decentralization. You're not just a passive ETH holder anymore. You're literally becoming part of Ethereum's nervous system, helping the network stay healthy and balanced. What you really get are benefits that money can't buy. Also, you don't need 32 ETH or even any ETH to run a node. So now that you know why you'd want to run a node, let's break down the different types of nodes you can actually run. Broadly, there are three types of nodes. A light node is the lightweight option. It only downloads block headers and asks full nodes for the rest of the data, making it perfect for phones or low-power devices. A full node is the standard. It validates blocks, keeps the latest state, and can regenerate older data if needed. This is what most people run, and it's ideal for wallets, dApps, and validators. And then there are archive nodes. These store everything, every single state since Ethereum's first block. They take up terabytes of space, but they're essential for explorers and analytics platforms. So depending on your goals, you can run a lightweight participant, a full validator, or a deep archive of history. But no matter which you choose, all of them depend on one thing: hardware. Hardware is the most important component to consider when you want to run a node. You can use your local PC, bare metal server, or cloud providers. However, if Ethereum is to be considered truly censorship resistant, it shouldn't rely too heavily on cloud providers. Yet today, a large share of nodes are hosted on the cloud. That's convenient, but risky. If those companies ever decided to block Ethereum nodes, a huge part of the network could go dark overnight. That's a single point of failure in a system designed to have none. The healthier path is to run your node on your own machine, whether it's a desktop, a laptop, a server, or even a single board computer. A dedicated setup improves performance, strength, and security, and avoids slowing down your personal PC. But what if using cloud providers feels too centralized and home hardware feels like too much? There's a middle ground: bare metal service providers. These companies rent out physical servers, not virtualized cloud machines, but actual hardware in data centers. It's still centralized to a degree, but it gives you more control and avoids over-reliance on cloud giants like AWS, Google, or Microsoft. So the strongest option is always your own hardware. But if that's not practical, bare metal can be a good compromise. The most important thing is making sure Ethereum isn't overly concentrated in one place. All right, let's get into the specifics. Running an Ethereum node isn't mining. You don't need a warehouse full of GPUs. What you do need is a stable machine that can handle the constant workload of staying in sync with the blockchain. The biggest bottleneck here is storage. Ethereum's blockchain is massive, and syncing it is very input-output heavy. That's why an SSD is basically required. A traditional spinning hard drive just won't keep up. At a bare minimum, you'll want a CPU with at least 2 cores, 8 gigabytes of RAM, a 2 terabyte SSD, and around 10 megabits per second of bandwidth. That's enough to stay synced, but things will feel much smoother if you go a little higher. The recommended setup is a fast CPU with 4 or more cores, 16 gigabytes of RAM, and at least a 2 terabyte SSD, preferably larger. For bandwidth, 25 megabits per second or more will keep your node happily synced without hiccups. Keep in mind, these numbers aren't fixed. Different Ethereum clients have slightly different needs, especially when it comes to storage. For example, Geth using SnapSync takes around 500 gigabytes, while Besu needs closer to 800. Nethermind is also in that 500 gigabyte range, but if you're running an archive node on Geth or Nethermind, you'll need a whopping 12 terabytes or more. Clients like Aragon and Reth work differently. They don't have SnapSync, but they do support pruning. That means you can hold Ethereum's full history in around 2 to 3 terabytes with Aragon, and about 1.2 to 2.2 terabytes with Reth, depending on how you configure it. And don't forget, execution clients aren't the whole story. Consensus clients also need space, about 200 gigabytes extra for beacon chain data. If you're running validators with a lot of keys, expect even heavier bandwidth demands on top of that. One last thing to keep in mind is your operating system. The good news is every major Ethereum client supports Linux, macOS, and Windows. So whether you're an IT admin or just running a home PC, you can choose whatever operating system you're most comfortable with. Just make sure it's kept up to date for security. So in short, Ethereum nodes don't require insane hardware. They just need stability, disk space, and a reliable connection. And by running one on your own machine instead of the cloud, you're making Ethereum stronger, more decentralized, and more censorship resistant. If you want to take the next step and actually validate blocks, you'll need to stake 32 ETH. A validator is just a node with extra responsibilities, proposing and attesting to blocks. But with that responsibility comes higher demands. Uptime is critical. If your node is offline too often, you'll face penalties. Validators typically need 8 or more CPU cores, 32 to 64 gigabytes of RAM, a fast 4 to 8 or even more terabyte SSD, and at least 300 megabits per second of bandwidth. You'll also want backups, like a UPS for power supply, and even a secondary internet line. It's not something to run casually, but for those who commit, it's one of the most direct ways to support the network while earning rewards. So how do you actually get started on running a node? First, choose your hardware, whether that's your own machine or a bare metal provider. Next, install your clients. If you like full control, the command line is your friend. If you want something simpler, tools like DAppNode make it much easier. Once installed, let your node sync with the blockchain and keep an eye on its performance. If you're brand new, I'd recommend starting with a testnet like Sepolia. It's a safe environment where you can learn without risking real ETH. Once you're comfortable, you can make the move to mainnet and join Ethereum's global network. Now, running an Ethereum node is more accessible than ever. Whether it's a light node on your laptop, a full node on your desktop, or even a validator staking 32 ETH, every contribution makes Ethereum stronger. By running your own hardware, or even choosing bare metal over cloud, you're helping keep Ethereum decentralized, censorship resistant, and resilient. If you've learned from this video, please like and share it with a friend. Drop a comment if you have any questions, and don't forget to subscribe to the channel. Thanks, and see you in the next video.